Hi, Corey Blankenship here to give you an overview of a LANDFIRE biophysical settings model. In this video, I'll be using the SyncroSim software and the STSim and LANDFIRE Veg models packages to demonstrate various features of a LANDFIRE biophysical setting model. You can download the software from the developer's website. One of the hallmarks of LANDFIRE models is that they are consistent. Of course, each one represents the unique dynamics of a biophysical setting, or BpS, but they all use the same naming conventions and utilize a standard set of software functions. Once you understand these elements, you can understand any model in the set. For this demo, I'm going to walk you through a sagebrush model. The first task is to find that model in the BpS model library. To do that, open the Reference Condition Model Scenario and select the Transition Pathways tab. Then click on the magnifying glass icon and scroll down. I'm going to select the Intermountain Basin's Montane Sagebrush step and click OK to open the Model Pathways diagram. All LANDFIRE state and transition simulation models will look something like this. Just looking at this diagram, we get a lot of information about the BpS. Each box represents a state. In LANDFIRE, we call states succession classes, or S-classes for short. Each state is identified by its cover type and structure stage. The cover and structure will connect you with the BpS description document. This is important because if you ever have a question about a model, you can go back to the accompanying description document for more information. The numbers in the box represent the age range of the state. This tells you how long a state will last if no disturbances occur. The last thing to look at on this diagram are the arrows. Green arrows represent growth or succession pathways. Blue arrows represent disturbances. This diagram gives a great overview of the successional dynamics of an ecosystem, but to understand the disturbance regime, you need to go a little further. You can double-click any state to access the probabilistic transitions table. In LANDFIRE, we use the probabilistic transitions to represent disturbances. In this state, you can see that there are several transitions. Let's walk through the wind-weather stress transition. Right off, you might be wondering, what does wind-weather stress really mean? In this case, it represents drought, and I know that because I read it in the description document. This drought can occur in the late 1 closed state and causes a transition to late 1 open. The probability of this event occurring is 0.0067. That's about a 150-year return interval. In English, this means that about once every 150 years, there could be a drought severe enough to kill some of the shrubs and open an old dense stand of sagebrush. Two other settings are used to control disturbances in LANDFIRE models. The first is age reset. For this transition, age reset is set to yes, meaning that if the transition occurs, the age of the simulation cell will be set to the start age of the 2 class, in this case, late 1 open. The last setting is time since transition, or TST minimum. TST minimum is used to attribute the time since a transition occurred. LANDFIRE only uses this setting with an alternative succession pathway. Since this is not an alternative succession pathway, the default value of 0 is used. You've now seen the states and transitions that make up this sagebrush model. Each LANDFIRE BpS model has a unique set of states and transitions, but they will all be attributed using the functions that we just reviewed. Remember to use the description document that goes with each model to get more information.